Boys, today we will discuss method of substitution. We have already discussed in the previous video the 6 formulae which are used as a tool for this topic. So you must keep in mind those 6 formulae, and now today we will try to complete this exercise discussing its different types. Now, in simple problems, we have to apply the formulae directly. But we should start here from type 1, that as soon as its complications starts, we will have to think in different types. Now, the type 1 that we have to discuss, type 1, that is integrals of the form dx divided by ax square plus bx plus c, or integral dx by root over ax square plus bx plus c. Whether this quadratic expression is without radical sign or with radical sign. How to integrate such type of integrations. Remember, this dx is free from any variable. There may be some constant here, say 2, 3, 4, 5, there may be, but it should not contain any variable, means like x. Similarly, here in denominator, we should have a quadratic expression. This quadratic expression without radical sign or with radical sign. Now, to solve such type of integrals, we will try to express ax square plus bx plus c as in the form take a common. That after taking a common, you will get x square plus bx by a, then plus c by a. Now boys, try to make it as a perfect square. So what happens? A in the bracket x square plus 2 into b by 2a into x plus b square by 4a square minus b square by 4a square and then plus c by a. So this is your result. B 2 into b by 2a, you can easily understand, 2 and 2 cancels out, so it becomes b by a. So now here we can write a into x plus b by 2a whole square, and then if you take the LCM here, minus in the bracket, if you take the LCM, you will get b square minus 4ac by a square. Now after taking this result in this form, we are able to integrate the two integrals. So our basic target is to make it a perfect square. Sometimes to make it a perfect square, it becomes more easier, but sometimes it is difficult to make a perfect square. So in that case, you have to apply this technique, 2 into b by 2a. Now let us start with an example. Say integral dx by I is equal to integral dx by root over 6x square plus 7x plus 1. Say 6x square plus 7x plus 1. You want to integrate it. For that, you have to write, we have, that is 6x square plus 7x plus 1 is equal to, you can take common 6, you will get x square plus 7x by 6 plus 1 by 6. This thing you will get in bracket. Now this is equal to 6 into x square plus 2 into 7 by 12 into x plus 49 by 12 minus 49 by 144 minus 49 by 144 plus 1 by 6. This result you will get. Now from here you will get 6 into x plus 7 by 12 whole square You see, x plus 7 by 12 whole square is this term. Now, if you take common here, minus, in the bracket you will get LCM as 144. Now, this becomes 49 minus, what happens? If you take minus common, here this plus becomes minus. That's why I am writing here minus sign. And then minus, here you will get 6 2 ja 12. That is 2, 6 4 ja 24. So what happens? You will get 6 in the bracket x plus 7 by 12 whole square and minus, here you will get 25 by 144. So this result you are getting after making it a perfect square. Now you should write, therefore I is equal to integral dx by root over. Now try to keep this value instead of this one. 6 into x plus 7 by 12 whole square minus 25 by 144. So this result you have written instead of this value. This radical sign remains here. No problem. Now what happens? After this, we have to evaluate this integral. For evaluation, remember, we should take this 6 out. We should take this 6 out from the integral. So what happens? You will have 1 by root 6 integral dx by root over. Then x plus 7 by 12 whole square minus 5 by 12 whole square. This is 5 by 12 whole square. Now, do not apply formula directly here. Remember it. In HS, it is restricted. So what you have to do, first of all, you have to take let x plus 7 by 12 is equal to z. Therefore, dx is equal to dz. This thing you are getting. Now, therefore, I is equal to integral dz by 1 by root 6 will be here. 1 by root 6 dz by root over z square minus 5 by 12 whole square. Now, boys, you know, this is of the form x square minus a square root over. And you know the formula. Formula is 1 by root 6. It remains here. Log mod z plus root over, that is z square minus 5 by 12 whole square. 5 by 12 whole square. So this thing you will get plus c. Now you have to put down the value of z. What you have assumed as z, that is x plus 7 by 12. That should be kept here. So what happens? You have the result as this is equal to 1 by root 6 log mod x plus 7 by 12 plus root over, that is x plus 7 by 12 whole square minus 25 by 144. So mod closed plus c. So this is your answer. There is no need to simplify it further. Yes, but if you want to match your result with your answer in book, you can simplify further. Means you can open this square, then simplify it. You will get your answer which is matched with your book. But this is your answer after applying the formula. And one thing must be kept in mind, that those 6 formulae you have to remember before starting these problems. Now, one more thing. Here, the problem differs either with radical sign or without radical sign. Now, if it is without radical sign, then we have a different formulae. And if it is with radical sign, we have a different formulae. Okay. Now, let us take one more problem. Integral I is equal to integral dx by 2ax minus x square. Suppose this is very important problem, boys. Now, to do this problem, you see here x square term is negative. So first of all, you have to take common integral dx by. You can take minus common. You will get x square minus 2ax in the bracket. Now, after that, integral dx by, you just leave minus here. Do not take it out. Then Here you will get x square minus 2ax plus a square minus a square for making it a perfect square. Now you see here, this one is a whole square. You will get integral dx by, that is minus x minus a whole square minus a square. Now one more thing you must take it here into account, that you should not write a minus x whole square. Remember it. You always try to write x minus a whole square. Now take this minus within this bracket. What happens is equal to integral dx by, that is a square minus x minus a whole square. Now, whether this exists with radical sign or without radical sign, this one is our simplified result after making it a perfect square. Now, do not apply formula directly. You have to take this one as z. So, let x minus a is equal to z. Now, this gives you dx is equal to dz. Now, what happens? After taking dx is equal to dz, we will have this I is equal to integral dz by, that is root over a square minus z square. And you know the formula for a square minus z square was, you know, yes, sorry, not root, without radical sign, it is a square minus z square, sorry. Now you know the formula for this a square minus z square. The formula is 1 by 2a log mod a plus z by a minus z, and then plus c. Now boys, you can keep z is equal to x minus a from here to here. What happens? That is 1 by 2a log mod here a plus z. So x minus a cancels out. You will get x, and in denominator x minus a, if you write here, it becomes 2a minus x mod closed plus c. So this will be your answer. So this is type 1, where dx is free from any variable. It may contain some constant, free from any variable, and in denominator we have a quadratic term which exists without radical sign or with radical sign. In both the cases, you have to make it a perfect square. Now, let us discuss type 2. Type 2. Integral